So, as we know that 8086 microprocessor is working in two modes. One is called minimum mode, another is called maximum mode. Okay. So there are two modes of operating system, that maximum and minimum modes. When it is this pin maximum and minimum is high, that means it is going to the minimum mode. And when it is low, this pin, that means microprocessor must be working maximum mode. So some other pin, pin number 28, it is a status line, memory or input output. The signal is used to distinguish between memory access and input output access. Memory access means microprocessor internal work. Okay. So when it is 1, it is working on memory. When it is 0, it will working as a input out. Next, write. The signal indicates that processor is perform a memory write depending on the state of MIO signal. So what is write? Simply when it is uh, high, in that time, this pin is not activated. When it is low, that means pin is activated. So in that time, write means if I want to write something in the microburst. So what is write? Write means suppose if I want data from one memory location to another memory location, if I going to change, it is called write. Even the uh, address of the data, if I change it, it is also called write. Okay. Next, pin number 24, interrupt acknowledgement. What I told before, the interrupt, if microprocessor accept the interrupt, after that microprocessor give a one acknowledgement signal through this pin number 24. That is okay, as you first user going to request the interrupt. After requesting interrupt, if microprocessor accept its request, in that time, it will give one acknowledgement through this pin 24. It is called interrupt acknowledgement. Next, ALE pin number 24, address latch enable. When it is high, 8086 indicates that high order address bus, it will be enable. So during T1 state of bus cycle, that means higher order address bus will be enabled if this pin is high. Simple. Next, data transmit and receive. Pin number 27. When DT it is 1, in that time data is transmitting. When this pin is 1, that means data is transmitting. When it is 0, that means data is receiving. Okay. Next, data enable. Signal provides an output enable signal for trans receiver 8286, 8287. That means it will provide a one enable signal. That means data is enabled or not. Next, hold. After that, hold acknowledgement. The two signals are there. When user requests the microprocessor, must that now it hold it, the work, or pause the work. It is called hold. And after microprocessor receive this signal hold, if microprocessor acknowledge this hold, that means okay, I understand you want to hold my work. After that, microprocessor again give one signal. It is called hold acknowledgement. That means it acknowledges the hold signal. When microprocessor going to direct transfer the data from one microprocessor to another microprocessor, in that time this signal will be used. It is called DMA, direct memory access. When it is happen, in that time, this whole signal we can uh, use it. Through this whole signal, actually, we doing this operation, DMA, direct memory access. After, when it is acknowledge this whole signal, again microprocessor send back one acknowledgement signal. It is called HLDA. That means hold acknowledgement. After that, some pin number 24, 25, some signals are there, QS1, QS0. When both are 00, there is a no operation. When QS0 is 1, it is QS1 is 0. First byte of opcode from Q, it will be go, or it will be fetch, or it will be execute. When S0 is 0, S1 is 1, the Q is empty. When both is 1, 1, subsequent byte from Q, it will be come into the for execution. That's all. Because opcode is going through Q. So this Q operation is decided by this pin number 24 and 25. Next, lock. It is pin 24. Active low signals indicates that other system bus masters are not to gain control of system while lock is activated low. Lock is activated by lock preface instruction and remain active until completion of next instruction. Simply, if I want to lock the microprocessor, in that time, this pin I need to use. So, when microprocessor is lock system, other any system bus or other any device, if it is connected to the microprocessor, it is not able to access this microprocessor. This is the another feature of 8086 microprocessor. So some status signals are there. S0, S1, S2. When S0 is 0, S1 is 0, S2 is 0, interrupt acknowledgement. When S0 is 1, S1 is 0, S2 is 0, input output read. When S0 is 0, S1 is 1, S2 is 0, input output write. S0 1, S1 1, S2 0, halt operation. S0 0, S1 0, S2 1, that means opcode phase, that means operation code. When I'm giving some instruction to the microprocessor, this is called opcode. When this opcode is understandable microprocessor, in that this is called opcode phase. Okay. Now 1 0 1 memory read, 0 1 1 memory write, 1 1 1 microprocessor going to the passive state. So this is the signals. With the help of these signals, we can able to doing writing, reading, opcode fetching, different type of interrupt acknowledgement we can do. Okay. So this is the signals are very much important for 8086 microprocessor. Some request grants are there. RQGT0, RQGT1 request grants it is called. Are used to other local bus masters in maximum mode to force the processor to release the local bus at the end of the processor's current bus cycle. So this is the all about the pin diagram of 8086 microprocessor. Thank you.